So now we're going to look at some practice problems where we evaluate inverse trigonometric functions. So first things first here, we want to make sure that we're looking in the right place. So what I mean by that is that if we're evaluating either the sine inverse function or the tan inverse function, we don't need to worry about looking at the left-hand side of the coordinate plane or the left-hand side of the unit circle. However we're thinking about this, we're only going to get pictures, draw some pictures in quadrants 1 or quadrants 4. So our answers are going to be in between negative 90 degrees and 90 degrees, or negative pi over 2 and pi over 2. Those are what the outputs are going to be. That's the range of the functions. And for the cosine inverse function, we're only going to look between 0 degrees and 180 degrees. We're only going to draw pictures in the first two quadrants. So that's sort of the first thing that you just sort of memorize those facts. And then the Khan Academy videos and in class we've sort of talked about why that necessarily has to be the case. So let's do some examples. So I picked some examples here where we could draw a picture, but we don't necessarily need to draw like a triangle. So I'm going to do some sine inverses and tan inverses first here. So I'm going to get rid of those two places. So here, let's look at this first one. When the sine value is 0, what is the angle? So remember, sine is the y value of the point on the unit circle. So if I just sort of label if I think of the unit circle here, if I just draw it in. So this right here is the point 1, 0. This right here is the point 0, 1. And down here is the point 0, negative 1. So if I'm looking for where my sine value is 0, that's right here. This y value of 0, that's a sine value of 0. And then what's the angle? The angle is just 0 degrees or 0 radians. Same thing if I hop down here to the tan inverse of 0. Remember, tangent is opposite over adjacent, or y over x. So if I look at this point right here on the unit circle, 0 divided by 1, the y value of the coordinate divided by the x value of the coordinate, 0 divided by 1 is 0. So the tangent is 0 at 0 degrees as well. So what about this? What about when the sine value is 1? Well, let's see here. Here the sine value is negative 1 at this point. Here the sine value is 0. Here the sine value is 1. So what's the corresponding angle? 90 degrees. Or if I'm answering in radians, pi over 2. Okay, now cosine inverse. I'll draw a different picture over here because cosine inverse, I'm not going to look down here. But again, I'm still thinking of the unit circle. So this point right here, that's negative 1, 0. That's where the cosine value is negative 1. When you're at this point right there, which corresponds to an angle of 180 degrees in standard position. Or if I'm answering in radians, that would be pi. So those are some examples where you can evaluate some inverse functions, and you're still thinking about like what quadrants your answer can be in and what quadrants your answer cannot be in, and you're thinking of the unit circle, but you don't necessarily need to draw a triangle per se. Okay, now let's look at some examples where I'm going to get some triangles going. So let's do this one first, the sine inverse of negative a half. So I'm not going to worry about those two quadrants. Okay, so I need to put my triangle either in the first or the fourth quadrant, but one of the sides is negative, so the triangle has to go in the fourth quadrant because everything's positive in the first quadrant. X is positive and y is positive. In the fourth quadrant, x is positive and y is negative. So that negative goes with this side right here because I'm going down. The hypotenuse is always positive. So if the opposite is 1 and the hypotenuse is 2, the adjacent must be root 3. That's a 30, 60, 90. And this angle right here is my 30-degree angle because it's opposite the side that has a length of 1. So now my angle here, I got to be careful. The answer is not 30 degrees because if 30 degrees is my answer, the triangle would be in quadrant 1. So since I'm in quadrant 4, so I've rotated from standard position sort of clockwise 30 degrees. So that's negative 30 degrees. If I'm answering in radians, that would be negative pi over 6. What about this next one? Cosine inverse negative root 3 over 2. Okay, so cosine inverse, not looking here or here. Okay, so again, points in quadrant 1, x and y are both positive. Points in quadrant 2, x is negative, y is positive. So my triangle can't go in quadrant 1. All the sides will be positive. It's going to have to go in quadrant 2. Cosine is adjacent, negative root 3, over hypotenuse of 2. That means that the opposite side's 1. So it's a 30, 60, 90. And again, this angle right here is going to be 30 degrees. But now I've got to be careful. My answer is not 30 degrees. Again, because the answer is 30 degrees, the triangle will be in quadrant 1. So the question is, how far have I come in standard position? So if I started here and I swung all the way around and landed right here, how far is that? Well, I got to think like if I went all the way back to the x-axis, that'd be 180 degrees. So I need to think sort of how much did I stop short of 180 degrees? I stopped short at 30, so I must be at 150. Another way you could figure that out, you could just do 180 minus 30. And if we wanted that in radians, that's, well, let's figure that out down here. So 150 degrees is 5 times 30. And 30 degrees is pi over 6, so this must be 5 pi over 6. Using some proportional reasoning there to convert from degrees to radians. If you don't like that way, you could always use the conversion factor. You could always just multiply by pi over 180. And then you could just reduce the 150 over 180 to get 5, 6. So I threw this slide on here to know some common equivalent values, because knowing that 1 over root 2 and root 2 over root 2 are the same sort of makes your life easier in terms of doing these problems. Same with 1 over root 3. That's the same as root 3 over 3. So let's look at an example. Like, what if you had to do, let's say you had to do, say, the tan inverse of negative root 3 over 3. And you were like, wait, opposite over adjacent. Oh, I don't like having a root 3 and a 3 in there, and or you get confused, you don't know where the triangle's going to go. Well, if you know that root 3 over 3 and 1 over root 3 are the same number, you could just do the tan inverse of negative 1 over root 3. And then that might be an easier problem, because then you know, okay, oh, opposite side length is 1 and the adjacent side length is root 3, so I got to be going, my picture has to look like that. Opposite side length 1, adjacent side length root 3. But now wait, one of these has to be negative. It's got to actually be the 1, because like this root 3 is positive, it's going over, and the 1's negative, so it's going down. Hypotenuse here would be a 2, and again that's a 30 degree angle, so my answer, since it's in quadrant 4, is negative 30 degrees, or negative pi over 6, if you're answering in radians. So the same thing with the value root 2 over 2. Like if you had to do something like the cosine inverse of root 2 over 2, you might be more comfortable making your triangle, or just using the ratio 1 over root 2, so that when you draw the picture for your triangle here, cosine inverse can't be, it's not going to go down here. Everything's positive, so I'll be in quadrant 1. Adjacent 1, hypotenuse root 2, opposite side will be 1, so that's a 45, 45, 90, the traditional 45, 45, 90, sort of the base case that we use all the time. So that's why I sort of thinking with the unrationalized ratio it's just sometimes easier, it works out nicer. That's a 45 degree angle right there, so this is going to be 45 degrees. If we're answering in radians, that's pi over 4. So just make sure that you're careful with where you're putting your triangles, and just practice a lot of these, because practice makes perfect with these inverse trig.